This is an AQA GCSE chemistry question. It's from Trilogy 2019 paper and it's a foundation tier question. Going to recommend you pause, have a go at the question before you review. So here's part A, part B, part C, part D, part E, part F, and finally parts G and H, a 14-mark question in total. So let's start the review. Question 1. A student investigated the rate of reaction between magnesium and hydrochloric acid. The reaction produced a gas. What gas is produced? Well, you have got to remember that a metal plus an acid will make a salt, and it will also make hydrogen. For part B, what's the piece of apparatus labelled A that we see here? You need to be able to recognise the key apparatus from delivery tube to bung to measuring cylinder. A is a conical flask. For part C, the student saw a reaction was taking place, a chemical reaction. Give 2 observations that would show a chemical reaction taking place. Well, you might see effervescence. If a gas is being produced, you'll see bubbles forming. You might see that the magnesium pieces are getting smaller as they react with the acid. And you might actually be measuring the temperature, and it's an exothermic reaction, so the temperature goes up. For part D, we have got some data provided. We've got part of a table filled in, and your job is to fill in the rest of it. Now, you have got to remember to include headings for each column. This one's been done, the volume is here, and you need to add that this is cm cubed. And then you need to add the times. Now it's 2 minutes every 20 seconds. We're doing it in seconds, so it's 20, 40, 60, 80, 100, 120. For part E, how could the student make the reaction faster? Well, if I decrease the concentration, it would make it slower. If I use a smaller volume of hydrochloric acid, it would make it slower. Using a larger measuring cylinder would make absolutely no difference, but if I increase the surface area of magnesium by turning it from a ribbon to a powder, increasing surface area does increase the rate of reaction. On to F, determine the mean rate of reaction for the first 10 seconds. So I have taken the data here, I've gone across to 10 seconds and drawn the lines up, and I can see that at 10 seconds I have made 28 centimetre cubed of gas. The gradient is changing y over changing x, provided already, so 28 divided by 10 gives me 2.8. Now I'm given this as a multiple choice, but I've got cm cubed divided by seconds, so it's cm cubed per second. On to G, determine the time at which the reaction finished and no more gas was produced, where we're looking for where it goes flat. So 59 or 60 gets the mark. Why does the rate of reaction increase when temperature is higher? Tick 2 boxes. Really important you read the question and not miss out there. Temperature does increase rate, or increasing temperature increases rate, and there are 2 reasons for it. One, there are more frequent collisions, and if there are more frequent collisions, there are more frequent successful collisions, and therefore the rate goes up. But also the particles have more energy, and that means that they're colliding harder, so a greater proportion of those collisions will result in a reaction. So to summarise, there's an increased frequency of collisions, and a higher proportion of those collisions will lead to a reaction. And that takes us to the end of this question.